If one AI judge plays favorites, the obvious fix is to use more judges. Average across a panel, let the bias wash out. The crowd corrects the individual. It's such a clean idea that a lot of AI evaluation pipelines just assume it works. So we tested it. Across 4 frontier models scoring 40 responses, here's how much bias disappears as you grow the panel from 1 judge to 4. And here's where it stops. The experiment is the same one I've been talking about in this series. 4 frontier AI models, Claude, Gemini, GPT, and Kimi, each wrote 10 responses to a shared prompt set, and each then graded every response from every author on a 5-rubric scale. 40 responses, 4 judges, blinded labels. From that grid, we can build any panel we like. A single judge, a pair, a trio, or all 4. And for each panel, we can compute one number. How much higher does a response score when its author is on the panel compared to when the author is not? The hope is dilution. If each judge has their own quirky bias and the quirks aren't correlated, then averaging more judges should shrink the bias toward 0. That's the wisdom of crowds argument applied to AI evaluation. So we enumerated every panel. For panels of size 1, 6 panels of size 2, for panels of size 3, and 1 panel of size 4. For each, we measured the self versus peer gap with Bootstrap confidence intervals. 2,000 resamples. Let's see what the dilution curve actually looks like. At panel size 1, the mean self versus peer gap across the 4 judges is plus 0.38. That's small only because it's a mean. The individual judges range from plus 2.4 to minus 2.9. At size 2, the panel mean is plus 0.19. At size 3, plus 0.13. And at size 4, the full panel of all 4 judges, the residual self-influence is plus 0.09, with a 95% confidence interval from plus 0.04 to plus 0.15. So yes, the bias shrinks, but the confidence interval at size 4 does not include 0. That's the headline. Even when you average across all 4 frontier AI judges, the author's own vote still tilts the panel consensus by about 1/10 of a point. It's a small effect, but it is statistically non-zero, and it is the floor of what a 4-model ensemble can give you. There's no magic in adding a 5th judge if that 5th judge is also an author. Every model brings its own opinions about its own work, and on average those opinions are warmer than the peers. The crowd shrinks the bias. It does not erase it, but the mean across panels hides something much more important than the dilution curve. The panels of size 2 are a clean illustration. The Claude+GPT panel shows plus 2.58. Both judges are pro-author. Their biases compound. The Gemini+Kimi panel shows minus 2.07. 1 mild self-favorer and 1 anti-self model, and the net is sharply negative. The Claude+Kimi panel is roughly neutral at minus 0.8. Same panel size, 3 completely different verdicts. Which judges you pick matters more than how many. So if adding judges doesn't reach 0, what does? The answer is structural. Look at the panels of size 3 that do not contain the author of the response. There, the residual bias is essentially indistinguishable from 0. Translation. The cure isn't more judges in general. The cure is excluding the author from their own jury. Peer-only review. As soon as the author is sitting on the panel, even diluted among 3 peers, the score still leans their way. This sounds like a small methodological point. It isn't. A lot of how AI systems get evaluated today involves AI judges. Preference data for fine-tuning. Best of N reranking, where a model generates several candidates and picks its favorite. Leaderboard evaluations that ask a strong model to grade other models. In many of these setups, the model being trained or evaluated is also on the panel. That residual plus 0.1 tilt is the tax you pay for letting the author vote. It's small per evaluation, but it compounds across the millions of comparisons that shape a model. Some caveats. The bias we're measuring is a within-judge gap on 40 responses, not the absolute quality of any model. Panel composition effects are larger than panel size effects, which means in practice the choice of which judges you trust matters enormously. Kimi's anti-self behavior actually pulls panels down, which is unusual and may not generalize. And the residual of plus 0.1 at full panel may shrink further with more authors. So this is a floor estimate, not a universal constant. The structural point, exclude the author, survives those caveats. The wisdom of crowds works on AI judges, partly. Going from one judge to 4 shrinks the average self-preference bias by about 3/4. But the last bit doesn't melt away by adding more of the same. To get all the way to 0, you need a different rule. The author is not on the jury. Peer review, structurally. The cure for self-preference isn't more judges. It's the right ones.